Hello everybody, welcome to my channel. Today we have a very good problem for you guys called the shortest path and binary matrix. So this is a very good problem, so make sure you pay close attention to the problem statement, right? So it says given an n by n matrix called grade, right? Return the length of the shortest clear path in the matrix. If there's no clear path, return -1. All right, pretty simple. So it says a clear path in a binary matrix, right, is a path from the top left to the bottom right, okay? So they've given us the definition, right, of the clear path, right? It's the path from the top left to the bottom right, all right? And those are the rules, right, for that, for it to be considered a clear path, right? All the visited cells of the path are zeros, right? So that's very important, right? All the cells are zeros, right, along that path. All the adjacent cells of the path are directionally connected, right? So pretty interesting, right? It says AE, they are different and they share an edge or a corner, right? Pretty clear, okay? So the length of the clear path is the number of visited cells of this path, right? Okay, so the task, right, is to find the shortest clear path in the matrix, okay? That's what we're tasked with, guys, right? So the clear path, no straight zeros, right? No ones, and all the adjacent cells are directionally connected, right? Okay, cool. So this example is gonna help solidify things, right? We see we're given this original binary matrix, right? We need to find a path, right, from the top left to the bottom right? So how do we go ahead and find that, right? Okay, we can go down. No, that path won't work because there's a 1 there, right? We can go to the right. That won't work as well, right? So does that mean there's no path? No, guys, right? We also, right, it's not 4 directional, right? It's 8 directionally, right? So we can do diagonals in this problem, right? So we can go just jump, go diagonally, right? Find that 0 and you just say, hey, that's the shortest path, right? The path is a length of 2 because that's the number of cells included in that particular path, right? So it's kind of what this is. Pretty simple, right? Even if this was 0, right, we would need to go from 0, boom, boom, it would be a size of 3, right? It wouldn't be good. That's not the shortest path, right? So we want the shortest path, just jump diagonally, right? And then just get that, right? So diagonals, we can go up into the right, or up into the left, or down into the right, or down into the left, right? So those are the 4 additional directions that we can do, right, in this subsequent problem. Normally it's 4 directional, right? So yeah, which is up, down, left, right. Pretty simple. So this one is a little bit more involved, right? But the same thing applies, right? So we start from the top left always, right? And then the destination is always the target destination is always the bottom right? So the shortest path, we can't go down, we can't go diagonal here, so we're forced to go here, right? To go to our right. Then the right could either go there, but I can just diagonally jump there, right? Boom, right? Then I see 0 and I go here, and that's the shortest path, right? There's 4 cells included along that path, so as a result, we return 4, right? Pretty simple. So this one will be interesting, right? It's gonna help us handle that, those kind of edge cases, right? So you see that we start off with a 1, right? The top left, right? So there's no way we can satisfy that constraint that says all the cells, right, are zeros, right? We can't do that, unfortunately. Okay, so right away I just return -1, right, to say that I'm unable to find like a path, right, that satisfies those constraints that you've given me, right? So that's what we would do, right? We want to do in process. We just check the top left and we check the bottom right. All day zeros. If they're not zeros, then there's no path straight away, right? So there's no need to even waste time going through large matrix, right? Right? So how do we go and solve this problem, guys, right? So you can kind of see that we're doing some sort of a traversal, right? And in a matrix, right? And we've done problems before where we have to traverse matrix, and we have that skill already, right? We've done it with breadth first search, we've done it with depth first search. We know those traversals that are needed, right, to traverse those type of matrix, right? So pretty much they're represented as a graph and things like that, right? We could use those traversal algorithms that we know of, right? So how do we go ahead and solve this, guys, right? So traversal of choice, right? Because we're trying to find the shortest path, right? Not the longest path or whatever, right? We're trying to find the shortest path, right? And normally when we need to find the shortest path and, like, with unweighted edges, right, it's good to use breadth first search, guys. You know what I'm saying? So the breadth first search will be very useful in this problem because it will lead us to our answer the fastest, right? Which is why we need that, right? Right. So because as soon as we get to the answer, we just return it right away, right? We don't care about any other answer that may come after that, right? Because they won't be the shortest, so it doesn't really matter, right? That's kind of why we use the breadth first search approach, guys. Right? Hopefully it makes sense. Okay. So that's kind of what we're gonna do. We're gonna use a queue. Breadth first search. We use queues. We always start with the initial thing, right? 0, 0, right? And destination is gonna be, right? We're gonna do a check as we process the node. Are you the last cell? If you do the last cell, we return you right away, right? So that's kind of how we would go about it, right? So we use a queue, and then to prevent ourselves from going back to a different cell we've already visited before, right, we're gonna use like a sort of a visited matrix as well, right? A Boolean matrix, right? That will keep track of true or false if a cell was visited already, right? And then we just traverse, and we'll keep track of the distance as well, right? So for example, right? So I think it'll make a lot more sense once I get through the code, right? So pretty much what we're gonna do, for each cell, we're gonna visit those 8 directional like things that we have here, right? So we're gonna go up, down, left, right, and then also the diagonals as well, right? And we, as soon as we get the answer, we return there. So let me start talking, and I'll start getting to the code. I think it'll make a lot more sense, right? So we're gonna start off with a queue, guys. Right? A queue is gonna be to store the coordinates, right, as we process the cells, right? And let's call it okay. Now that we have that, right, what's next for us is to, I told you that we're gonna have this 2D array, right, to help us in keeping track of the cells we've visited before, right? So n, let's go ahead and grade that length, right? So we're gonna do that check that we talked about earlier, guys, right, where we check whether the first let me see. All right, so we're guaranteed at least 1. Okay, which is good. All right, so I will need to check for the length. Okay, so we do n. So let's do let's check the first cell, right? Check the first cell. Does it does it equal, is it not equal to 0? If that's not equal to 0, or the last cell, right? All right, does not equal to 0. We return -1 here, guys, right? Because there's no path that satisfies the constraint, right? So now that we've gotten this out the way, all right, we can start, our breadth first search, right? So we're gonna add every time, right? We're gonna add that initial coordinates, right? 0, 0, right? Because we start from the top left cell, right? Okay. And also we're gonna keep track of, we're gonna also add like the distance, right? So that's the distance, so to account for that cell, right? Because the length, right, is the number of cells along that path, right? So I put a 1 to account for that first cell that we're visiting, right? So okay, so it's at least of length 1. Okay. Okay, so what's next for us now is to just have a while loop, right? Start our breadth, right? So it's pretty standard and how we do it. Okay. So we're going to process things. Current cell. We're going to take it out the queue, so we can start processing, right? So one important thing that we need to do, right? We need to have the directions, right? So we need to define them, right? So let's quickly define the directions, right? So one thing that I was missing, right? So okay. Okay, so now let's start, right? So we're gonna do, let's do left, right first, right? Left, right. So we go right, let's go left first, and let's go right. Okay, so now we've taken that part. No, so now let's go let's go up, let's also go down, right? Okay. So what's next for us now is to, so let's go up and to the left, right? Let's also go up and to the right, okay? So now we need to get into the get down case, which is we go down and to the left, and then we go down and to the right? So we've taken care of all 8 directions, right? That we can go in for a particular cell, right? You know, so okay. So we get one cell thing out, and we do a check, right? Each time. If. So let's get a row. We go to current cell. Current cell data. Let's call it that, right? So the row is, you know, the first one, and then we have the column here, okay? And the second index, and then we have the length, which is index 2, right? Okay. So now we're going to check, right? If the row is equal to n minus 1, and at the same time the column is equal to n minus 1, then we have arrived to our destination, right? And we return right away the length of that particular path, right? Otherwise, if we're not there yet, right, we're going to need to visit the other directions that we have, right? Okay. So we're going to visit our neighbors, right? So new x. So our neighbors, right? You know. So we're going to check. So we're starting off at so the row that we're on. So the row. So for example, right, is 0, 0, right? So now we're going to need to go in all the direction, right? You know, left, right, up, down, diagonally as well, right? This is exactly what we're doing, right? See the piece of code that, you know, changes those coordinates, right? So we can go to the different places, right? You know, so it'll be whatever the row is, right? Which is 0, 0, right? Then let's say we get this one first, right? It'll be 0, 0, right? So it will stay here, and then it will go up, right? Now it will go to the left, right? So it will stay in the current row, and it will try to go to the left here. See exactly what it's doing, right? It's changing it, right? Okay, hopefully it makes sense. Okay, we have that. And the new, maybe I could make it even better. New row, new call, right? It'll be the current call that we're on, and then there one, right? Because that's for each direction, right? You know, this is for the row, and this is for the column, right? Okay, and now that we've got those, so what's next for us is to okay, so we need to check for the if we are in bounds, right? If the new row is less than 0, right, then that's bad. Or the new row, right, is greater than or equal to n, right? That's bad as well. Or the new call is less than 0, or the new call is greater than or equal to n. Or, right, another, like all the cells along that path, right, they need to be zeros, right? So grid of, you know, the new call, right, new row, if that's not equal to so let me make this down. If that's not equal to a 0, then that's something we'll pass on, right? So, and also if it has not been if it has been visited already, then we want to also skip it. Okay, then we can do continue. Okay, so if none of those hit, right, those conditions, then we go ahead and we add it into our queue, right? You know, so it'll be pretty. So it'll be the new row, new call, right? And then the distance, right, which is the length plus 1, right? The length of the current cell that I'm on plus 1, right? Because, you know, this is one extra cell that we're gonna visit until we get to the bottom right? So, all right, and then as we do that, we're also gonna do the visited new row, which is our neighbor row, and new column, right? You know, Maybe I should call it nade row, nade column, right? But yeah, hopefully makes sense. Let's set it to true because, you know, we will say it's visited. Okay. What's next for us? Let me zoom out a little bit. So big. Okay. So what I'm going to do here is to also, since we're visiting the first one, right? We need to make sure that we also mark it as visited. Okay. And then we keep doing that, and then at the end, right, if we never get to a path, right, that leads to the bottom right for whatever reason, right, then we return -1, right, because we never, you know, hit that condition, right, where we hit that, right. Okay, right, so hopefully it makes sense to you guys. So we wanted to use the breadth first search because we want the shortest path that leads to the bottom right, starting from the top left. We start our breadth first search from the top left, right, and then we also keep track of, you know, in our data that we're storing, right, the length of the current path, right, and then we keep incrementing every time by 1, right, and then we check all 8 directions, right, because, you know, rooted at that, you know, particular cell, right, up, left, right, down, diagonally, right, you know, all those things, right, and then we keep doing that. We visit all the cells, right, and we only visit them if there are zeros, and also if they have not been visited yet, right. So that's one reason, right. So let's run code, see if we made any small errors. Of course we did. I put a dot. I meant to put a comma. Right? Let's press run code. All right, looks like we have a small test case. Press submit. Awesome, guys. We were able to pass all the test cases, guys. If you guys found value, you guys understood the thought process and whatever I was trying to explain, let me know in the comment section. If you guys are new here, make sure to subscribe because we'll be doing a lot of other videos just like this one. So I want to thank you guys for watching, and I'll see you guys in the next video.